Grace and peace be multiplied unto you. I welcome you to today's lesson in science on the topic electric circuits. So, in our previous weeks, we've looked at electricity, we've looked at the use of electricity in our homes, and the rest. So, actually, one thing just to remind us is electricity is the flow of electrons. Okay, so today, this week, we are going to look at electric circuits. We're going to look at electric circuits. So, what is an electric circuit? An electrical circuit is a device or is an electrical device that provides a path for electric currents to flow. Okay, so electric circuit basically are devices that provide a path for an electric currents to flow. So electric circuits are made up of electric components. Electric components. So all the things you see around here, all the things you see around here, sorry, all the things you see around here are electric components. Okay, these are parts. So components means parts. So it's just the things that make up an electric circuit. So every electric circuit has constituents or has certain components that make up that circuit. So these components must be joined together without any gap between them to form what we call a closed circuit. So we get to know what a closed circuit is. Now when we say the components we're actually referring to lights, light bulb, the wires, and then the battery. So in this electrical circuit here, we can see that there is a battery here, and there are two wires here, and there's a light bulb here. Okay, so the light bulb and the board is actually the circuit board. Okay, and then the connecting wires are also here. So those are the components of the electric circuits. And these are the components, or these are the things necessary for you to make an electric circuit. So like we mentioned that if there is a connection of wires and battery and lights without any gap, it is called a closed circuit. It is called a closed circuit. But then once there is a gap, there is an opening. So an incomplete circuit is called an open circuit, because when you take a look at this picture right here, you realize that the wire connects the battery to the bulb, okay, but then the other part doesn't have a wire to connect it. You realize that the other part doesn't have any wire to connect it. Okay, that wire is missing. Okay, so it's called an incomplete circuit or an open circuit. So the same way we have on the other end, we have the wires present, but then there's no source of energy. There isn't any battery to actually produce electrons for it to power the light bulb. So this is also an incomplete circuit. So both circuits in the diagram are incomplete, hence they are known as open circuits. So open circuits, there's actually a gap preventing the flow of electrons or electricity. So an electric current flows when there are two things. When there is an electric energy, a source of electric energy, and when the circuit is closed. Okay, so when there is a source of electric energy, example, battery. So battery is a source of electrical energy. A battery is a source of electrical energy. And also, when the circuit is closed, there isn't any gap in the circuit, then there will be an electric current flow. So you realize that the electric current flow moves from this way. Okay, you can see the arrow. You can see the arrow here. It moves from here, here, and into the light, and then flows from here to this part, and then back again. So that's the flow of the electric current, which makes the light bulb light or turn on. So let's look at how to draw circuit diagrams. Circuit diagrams. So for every electrical circuit, it's necessary that you are able to actually represent them in a diagram form, because you cannot be able to draw batteries and bulbs in your books if you want to draw an electric circuit. Now, for electrical circuits, you can actually have a very complex electrical circuit for a room or a very big place. And so you can't be drawing batteries and bulbs and the rest, but then you need simple diagrams to represent each component. That is why it's very important to learn how to draw circuit diagrams. Okay, so for a component like an electrical cell or battery, the drawing is this way. Okay, that's the drawing. And for a light bulb, this is the drawing, a simple drawing such as this. And for connecting wires, this is it. So any connecting wire is drawn this way. Okay, and if the battery is 2, you draw it this way. So you need to learn how to draw them. If the switch, so for an open switch, this is how you draw an open switch, and for a closed switch, this is how you draw it. Now you realize that for a closed switch, this line actually touches the other line, but for an open switch, the line here actually opens, so it doesn't touch this part. Okay, and connecting wires that has been joined, there's actually a dot in the middle there to show that there are two different wires, but then they've been joined together. Two different wires being joined together. Okay, so symbols are used to represent various electrical components in circuits. Now let's look at more of the symbols. So this is a switch, and this indicates that the switch is open. Okay, this is a bulb or a lamp. This is a switch indicating that the switch is closed. This is an electrical cell or a battery. Okay, this is what we call a resistor, so you can ignore these ones for the meantime. This is what we call a resistor, and an ammeter is this. An ammeter is actually used to measure the electric current passing through your circuit. So ammeter is drawn this way, a circle with an A inside. Okay, so for now you can get to know this, that, this, and this. So basically these are the things I require you to know. The rest are not very important now. So for the switch, very important, open and close. Electrical cell, you need to know how to draw it. The lamp, you need to know how to draw the lamp. And the ammeter. Okay, now, so a simple line is used to represent the wire, as any simple line is used to represent the wires or the connecting wires. So if the battery is more than one, you realize that these, you can tell that the batteries are actually three, because we have one, two, and three different batteries. Okay, and when the wires are joined together at a junction, this is how you represent them. Okay, and the rest are actually not very important right now. So you should know if the number of batteries are many and the joining of the wires for now. Okay, and an additional thing, for magnetizing coil or conductor, you always see a drawing like this, and a fuse too looks like this. So keep these drawings in mind. But for now, just leave this ones and learn how to draw these ones. So one, two, three, four. Okay. All right. So can you predict how this circuit would look like if in its schematic format? So I'm going to draw this one for you. Now when you look at this, you realize that the wires are this way, okay, and then the battery is something like this. Sorry, something like this. Okay, with here being the negative and here being the positive, because it's just one battery. It just being a battery, and then it connects again to the light bulb, and the light bulb is drawn like this to this part. So a simple diagram as this represents what we have here, and basically the same thing to this. So you draw them double. So let's look at switches. A switch is used to open or close a circuit. So in order to open or close a circuit, we use what we call a switch. And switches, like we saw, are drawn this way. Okay, so this is an open circuit, and this is actually a closed circuit. So this is a closed circuit and this is an open circuit. So switches are used to open or close a circuit, and switches are used on circuit boards. So let's look at the last thing and then we are done in this topic. We have what we call series and parallel, and these are two ways with which electrical circuits can be arranged. So sometimes you can arrange electrical circuits or the components of an electrical circuit in two types. We have the series type and then the parallel type, and we'll get to know what this entails. So when we say a series circuit connects the components one after the other. A single loop is formed. The loop simply means the wire. So a single loop is formed. A break in any part of a series circuit stops the flow of electric current in the whole circuit. Okay, so what it means is that for a series circuit, the components actually follow each other one after the other. So you look at these bulbs right here, they follow each other. Bulb 1, bulb 2, bulb 3. They follow each other one after the other. When you look at the battery, they follow each other one after the other. Battery 1, battery 2. So for any series circuit, once there is a breakage, for instance, let's say this wire here is torn, then all the lights here would not work again, or the electrical flow from here cannot pass here again, then all the bulbs wouldn't work. Okay, so that is the series circuit. The components follow each other one after the other. Now let's look at the parallel circuit. Now for the parallel circuit, it divides into two or more branches. So it divides the circuit into two or more branches. The current divides and the flow through each parallel branch also divides. So if a component break or is removed, the other component remains on. So for instance, electrical flow flows this way from here going. So it flows from here to here, also flows from here to here, and flows from here to here. Now imagine that there is a break, okay? There's a break somewhere here. This light might not come on, but then the rest of the lights will come on, okay? Because once there is a break here, it means that the electric flow is actually not flowing to this bulb. But then remember that this one is still connected to the battery, and this one is still connected to the battery, okay? If there is also a break here, there's also a break here, this one is still connected to the battery, so it will light on. The third one is also connected to the battery, it will light on. But then this one that has been broken wouldn't light on because the wire has been torn. Likewise, if this last wire has been torn, okay, this bulb wouldn't light on, but this bulb will light on and this bulb will light on because the circuit is still complete. It's still closed. There's no breakage. The breakage only came here. If the breakage is also here, still the light would flow. If it's here, the light will flow. So when it comes to when it comes to sorry when it comes to parallel circuits, the electrical flow is being shared. It's being shared for the three bulbs. So you realize that they don't bright very well, okay? Because the power is one, but then it's being shared for this and shared for this and that. So electrical bulbs in a parallel circuit don't bright clearly. So which of the following circuits is series and which is parallel? So of course this is series and this is parallel. So let's look at an example. Which is brighter? So this is a series and this is a parallel. Now of course a series is going to bright than a parallel because they actually have the same amount of electric current passing through it. But this one, the electric current will be shared between this bulb and this bulb. So series always bright than parallel. So that's the end of our topic, electric current, and I hope you enjoyed the lesson. I have given some exercise and I hope this video will help you solve them. Until we meet again, enjoy your day and have a nice weekend. Bye bye.